I think Dolores ran me last minute. I emailed yesterday that hey, you have this open slot. But so every time I give this talk, it changes a little bit. And one of the things to know is that the title has changed a bunch. And really the title that should be mock L. I think that's appropriate for describing some of the things I'm going to talk about. So I'm a staff software engineer at PITA. I work on a bunch of platform engineering. And what PITA does is natural language processing, machine learning on unstructured text. So this picture right here is basically a visualization of the conversation around the future of air travel that's based on search and polling news and blog sources. What I do day-to-day is a mix of data engineering and microservices. Practically, that means I'm working in Python and Flask 99% of the time. Also doing a little bit of Scala with some Spark, RabbitMQ, and Kafka, and those kinds of things. Python is actually about my fourth language, and I've only been doing it professionally for about 4 or 5 years. Before that, I was doing a lot of C++ for Java. And the reason that's relevant is because I think it creates a different style of thinking about structuring code and using mocks and doing testing. And so this title mock hell actually came out of a comment another developer made one day where she said, I'm in mock hell. And I didn't really understand what she meant until I started looking at our code base and seeing what's going on. And started raising all these questions for me about why people had all these troubles with mocks. So you might be probably used mocking and patching before. So this is going to be like an intermediate advanced talk. Maybe you use the mock and patch API regularly, but not sure why. Sometimes it's so messy or difficult to use. Or you're really comfortable with mocks and you just are curious about different ways people use them and different opinions. Some things you might learn: what are different styles of unit testing? Where did mocks really come from? What are the alternatives to mocking? What are anti-patterns of mocking? What's the relationship between mocking and design? So, just like Dante had 9 circles of hell, I think there's different levels of mocking hell. And like for me, this is what I would consider like 8 basic levels. There's probably more. Right, the simplest level up top is just the complex patch targets. Those are very confusing for everybody the first time you start using patch. Eventually you figure it out and it's not terrible. But things get worse the further down you get this list. So in the worst case, you end up with things like mocks that are just returning mocks that are returning mocks. You have tests that test nothing. You end up using a debugger to test your mocks. Or you have mocks that are actually preventing you from refactoring your code. And so I started asking myself, why does this happen all the time? Why is this so common in our code base? And so I just started looking at all the blog posts I could find and reading a bunch of books I could find on mocking and testing and patching, both within and outside of Python. I think I identified this pattern where when people go to learn about mocking, they'll go find some tutorial in your blog and it will say something like, mock is this cool library to isolate code for testing. And then I'll say, here's how you use magic mock, patch spec, auto spec, side effect, and so on. Patching is key. Make sure you use the right namespace target. And then that's about where it ends, feels like. And so what happens is there's some kind of example like this. You have something like my module. It uses another module called DB, and the function uses DB. The code under test is total value, which is just reading a list of items from that item ID, and then summing them up to get total value or total price. So if you're not familiar with mock, this is what a very basic usage of mock looks like. So what you do is you apply this patch statement to this thing you want to mock, which is DB, and you get this mock DB instance. On this line, you set it up to return a can value or stuffed value. You call it to assert on and then assert on the return value, and then you assert on the side effect that you made as a result of calling total value. That's pretty straightforward. And if I'm going to draw this picture, it looks something like this. Total value is what I'm testing. DDB is the dependency I want to get rid of, or decouple. So I run my test. I apply the patch. I substitute them off. Run the code under test. Assert on the result. And then assert on the interaction that just happened. So if you take that kind of idea and apply it to a more real example, this is an example I just picked up. So the Guardian, it's an English news website. They provide a search API that lets you query for all articles in the database over a certain time period. So the problem this sample code is solving is given some topic of interest, find all the relevant articles from a date range, and then feed those articles to a web scraper service. So the REST API is pretty simple. You just get on a search route, give it some date range parameters, query string right here, and then maybe get a feed. And then here's an example of what the response looks like, which is the blog with a page index, page size, number of pages, and a list of results. And within each result, you want to grab this web URL field. That's what you want to feed to the scraper. So the main function of this program is pretty simple. You just construct this feed class with your query and you run it. This is what the feed class looks like. It has 3 functions or 3 methods. So this constructor, very straightforward, takes the query string, the number of results you want per page, or page size, the date range, and then the host name of the Redis connection. So the way we're going to connect this to the scraper is by pushing everything into Redis. And so it's just initializing itself, constructing a Redis connection, and constructing a request session object to hang on to a connection pool because we're going to be making a bunch of HTTP requests. So the next method is this format request function. All this is going to do is it's going to take in the page number you want to retrieve, and there's a bunch of formatting to get the parameter strings or parameter dictionary, and then it constructs this request object and a get HTTP message with the correct URL and the parameters. Finally, there's the actual run function. All this is going to do is just going to keep pulling pages as long as they're pages. So this first chunk is going to send a formatted request, then it's going to grab the response, parse out all the pages or parse out the page, and get the results. And for all the results, it's going to grab web URL and then push it to the Redis connection. So the syntax down here is a little bit weird just because I had to fit everything on a single slide. Okay, so if I want to draw it as a picture, it looks something like this. You got your feed class that uses Redis request session. You got your external systems in white. You got your test. So you're going to patch, substitute the mocks, run the code, and then you check on that syntax. Right. So being a test, this is the thing under test. Set up my patches so I know I'm going to patch those 3 things. Then I set up, this is basically like the stub value. So this is a canned response that I'm returning, which is a page with 2 results. And I'm setting up the request session to return that. Then I'm doing my assertions on the calls to the request library. I'm making sure that I got this expected call to request, and it's building a get message. And then finally, I'm making assertions on the Redis code, or the Redis connection calls, and making sure I'm getting all the URLs that I'm expecting. This is an American cartoon, I don't know. Familiar with understanding, but anyway, when I'm dealing with code that looks like that on a larger scale, basically this is the kind of mood I get into. Things can get very complicated very quickly when you're using mocks like that. And there's a couple ways to think about this, right, other than to say, oh, this is terrible. So, right, one way, I would rather be able to say something very specific about why things are hard or difficult. So one way to think about this is ask how many mocks are in this code. And who here thinks it's 3 or 4? Who thinks it's more than 4? Yeah. So do with the way magic mock works, where it's automatically creating mocks for you, undefined functions or methods. So the other question is, when I'm looking at this, is like all these lines that are highlighted, is that really essential behavior of this P class, or is it just an implementation detail, a bunch of implementation detail? And you want to be like even more picky about it. Like, you can make an argument that these patch statements are very invasive and they're violating information hiding encapsulation because they know the exact support path of that P class. Go back to here and also look at all these particular recursive or deep mocking setups. And I think you can make a strong argument that this is a log to meter violation. So that's an idea that comes out of object-oriented programming. What it's basically saying when you're making these deep chain calls into an object that's very invasive and you're getting information you shouldn't really be getting at. The other way to think about this is say, okay, if I make this change in the code, so I change the import statement from this to this, right? That's actually going to break this patch statement. So that's implementation detail. It's not really that important, but it's going to break all my tests. Same thing if I make a change on here, on this request object from keyword args to args. That's also going to break this patch. There's a bunch of other examples of ways that can happen. So I think what's happening, how people are getting in mock cattle, is that a lot of times there's like this fine print kind of tutorials where it's like, by the way, be careful about over mocking, right? But it's not very well explained or it's ignored. And then every once in a while you see this phrase, mock smart stubs. And I think that's also important to understanding how to mock well or why people get the problems with mocking. So the other thing I did is I went and I just found as many mocking videos like icons. And they kind of more or less fit the same pattern. There's some variations on this. There was one from Cleveland last year called the Find the Patch function, which was actually really good. But something really interesting happened at the end of it. There's a Q&A where somebody asked, I spend so much time maintaining all my tests because they're so heavily patched and mocked. And what's your advice? And the presenter said, hey, patches get epic out of hand. Maybe you need to look into why there's so much heavy mocking. And then the interesting thing happens after that. So this is an example of the fine print. Interesting thing is that somebody comes up a minute later and says, hey, that was a really good talk. I'm Michael Ford. I was the original author of mock. One thing I would say is that patches are a sign of failure. The more you have to patch, the worse your code is. So that advice is, I think, 100% correct. But if you're having problems with mocking, it's probably a little bit cryptic and hard to understand. What do you do with that advice? How do you use that to make your code better? So that's what I want to dig into these other slides. And so what all that advice is pointing at is this idea that there should be this feedback loop between your code and your tests, where your tests are informing you whether there's a problem with your code and your interfaces and abstractions, and then your code determines what your tests like, which then reflect the quality of your code and so on. So if you really want to understand that, the question asks is where did mocks come from in this book. And if you go to Appendix A, they talk about the history of mocking, how they came up with mocking while they were doing extreme programming, TDD, object-oriented programming in Java. And so if you're having trouble with mocks, this is a good resource to go into because they will tell you all that, like a lot of mistakes people make and so on. Before they wrote that book, they actually published this paper called Mock Roles, Not Objects. And if you just look at the abstract, I think it tells you a lot of what you need to know. Mock objects is an extension to TDD that supports object-oriented design. Turns out to be less interesting as a technique for isolating tests than is widely thought. That's exactly the opposite of what you'll read in a lot of material about patching and mocking. They'll tell you exactly this. It's really useful for isolating tests, isolating code in your tests. So the way I look at it is that if you're having problems with mocking, it's probably because there's some misunderstanding of one of these three things, of either doing TDD or not knowing enough object-oriented design, or just thinking that mocks are just this thing you use for isolation. The other really interesting thing they say in there is, mock objects is designing, and it's no substitute for skill. And then they flat out tell you that mock-based tests become too complicated really quickly when the design is weak. And using mocks, if you don't understand how to do them, are going to amplify problems like tight coupling and misallocated responsibilities. And so that's one of the reasons why some people don't like mocking. This is another example. So this book is actually written with C# examples, but they're going to say things. This guy's going to say things like, always choose interaction testing as the last option. It's very important. Not everybody agrees. If you're enterprise, advocate what many call the London school. So sometimes you'll hear people talk about London versus Detroit style TDD. Get into that in a minute, right? But he's making the argument that mocks just creates a lot of trouble and it's not worth it. How am I doing on time?
Yes, 10 minutes, but if you need more.
10 minutes. So then the question is, all right, if I'm having problems with mocks, what do I do about it? And I would test without them. So this was that fifth point in fine print, that mocks aren't stubs. And, I was being a little bit of a smart aleck here. So I actually had 45 minutes for PyCon, so I'm going to cut to the chase on these things.
If you need 5 minutes more, it's not a problem.
So what this title is referring to is this is a well-known blog post called Mocks Aren't Stubs, and it's talking about different kinds of test doubles and this London versus Detroit style TDD. And if you're not familiar with test doubles, it's this idea that a test double is just a thing you can substitute in for an object while you're testing code. And a mock is one kind of test double. There's also things called stubs, fakes, dummies, and spies. I just want to show some of these by example, but I'm going to fill out the rest of this chart here just for reference if you come back and look at this. But if you just search for mocks aren't stubs online, you'll find all the information on there on what these things are. So if you go back to the toy example we had, my mindful.db read and test total value. This line right here where we set up the DB return value, that's an example of a stub. It's a stub because it's always going to return the same value no matter what you pass in as input. And then the mock part is because it's asserting on the side effect. So it's asserting that DB read is called with this specific item ID. So one alternative I like is this idea of using fakes. So if I bring this back to something simpler, we're still going to use a patch. And I'm going to create a fake DB read function. So this is a function that emulates a very simple version of the logic that DB read is implementing. But instead of going out in a database, it's just going to pull something off the file system, a fixture that I've constructed. And then I'm going to substitute it in using this new parameter called on the patch statement. So I'm find my patch and substituting in fake DB read. One of the things about mock is it doesn't explicitly talk about test doubles. So it uses some kind of different vocabulary. So it can do all these things where it acts like these other test doubles, but it's not always obvious how to do it. But anyway, so back to this example. So all I'm doing is I'm applying my patch, substituting a fake, and just asserting on the return value. I don't care about the side effect because that's kind of an implementation detail. And so if I draw a picture, got my test, still applying the patch. I'm defining a fake, which is this fake DB function, which is going out to the file system. It's going to sub it in, and it's just going to run it and assert on the result. Other option is, instead of using cache, I can just do dependency injection. So to do that, I need to change my signature a little bit in my want to do Marxist or classical style testing, or London versus Detroit style. Sometimes you'll hear that. Or you're going to patch or inject your mocks or your test levels or your dependencies. So if you go back to the Guardian example, it's just like a little map of some of the tactics I'm going to apply. I'm going to use this plan to keep track of where we are. So first thing is this idea of mocking roles and not objects. And I'm just going to try to explain that by example. So the question is, what are the roles in this collaboration? And I say Yoda and are collaborating in roles of master and student. They're filling the roles of master and student. But another part of the story is Obi-Wan and Anakin are master and student. Another point, they're hero and villain. Another point, it's actually Luke and Darth Vader. But then later in the story, they're playing the roles of father and son. So when I'm looking at this code, the question I'm asking is, what are the roles in this collaboration? And I would identify those three things as a role. You need something that's filling the role of the source. You need something that's filling the role of the sink, and then you need some parser that's connecting them. And so if I'm going to mock, those are the things I want to drop in the ball. That's kind of the intro to all these other tactics. First tactic is I'm going to look for it at the seam and try to patch a fake. So this is where we left the test. And I'm going to bring it back to here. So we got to deal with this Guardian dependency, this REST API dependency. So what I'm going to do is look for a different seam. Right? And the seam is this term coming out of refactoring techniques where it's just some place where you can substitute or you can alter behavior in your program without editing in that place. It's a little bit complicated to understand. Just as an example, in between the session and the Guardian, there's multiple seams I can exploit. So if I'm on a patch and mock, I could do it at the TCP connection level. I could do it at URL 3. I could do it at requests inside the request library. And as it turned out, there's this handy library called htmock, which lets you mock the rest of the content. And I'm going to use that to substitute a fake Guardian implementation. So that fake Guardian implementation looks like this. There's just some code that is taking in a URL and a request and pretending like it's the Guardian API. And I'm using htmock to divert any calls to this host into this function. And I'm patching that fake around this call to the feed. Right, so that lets me get rid of all the mocks and patches around HTTP. Second tactic is we're just going to apply dependency injection. So I'm going to change my code to look like this. Create a fake Redis, and then substitute it in and insert the state of fake Redis instead of calls to fake Redis. So the change I want to make to my feed class is instead of passing in a Redis host, instead of doing this, I'm just going to inject the Redis connection. And then I'm going to bring in this third-party library called fake Redis, which creates an in-process Redis server, inject it in a constructor, and then my assertions are going to change. And instead of asserting on a side effect, I'm going to assert on the state of things inside the fake Redis connection. Fourth tactic is you just inject the collaborator. So it's pretty similar. The Redis connection isn't really the collaborator. I don't really care about using Redis in the feed. I just care that there's a sync. So I'm just going to change my feed class to take in some function that acts like a data sync. And then I'm going to change run just to send stuff into that sync. My test becomes like this. I get rid of all the Redis mocking and patching. I just use a list, and the append function on the list is the data sync. It makes the assertion really simple. And then I do have to make a small change to the actual application main function, where I create the real Redis connection and the data sync function, and there's no I/O in this code. It's just pure transformations. So it's pretty trivial to test this. Right? And then, right, there's not anything here to really unit test. You can just integration test this. So I have a bunch of anti-patterns here. I'll cover the first one. So the first anti-pattern is bootleg TDD, and where that term is coming from is my friend who likes to subscribe to an Instagram feed of fake toys. So he shows me toys like this. And so what I mean by bootleg is something that is kind of right, but is a little bit off and not like the real thing. So that can happen in a bunch of different ways. Maybe that's like, you're somebody, like you got a developer who's trying to get 100% test isolation, 100% coverage. They're kind of testing whenever is convenient and not refactoring, and maybe they're doing some kind of top-down design. So if you're not familiar with top-down design, it's kind of you take your abstract function, you break it into smaller ones, something like those, keep breaking it down, and you get out into more and more detail. That might look like this. You have your program P, you break it into P1, to break those into smaller, even lower level details. And then you finally get your database. And then when you test, you want to get max coverage and max isolation. So you test and you mock, test and you mock, and you do your bottom level tests. Got a problem where you got to pass your database, and so what do? You like mock the database connection, or you mock the query language. Can do that, but it's very brittle, and there's specific reasons you don't want to do that. If you want to understand why, you go to the free enterprise book. And I have a bunch more patterns here, but I think I'm at my limit. So let me just forward through some of this. So there's this kind of deeper connection to good design, which relates to dependency inversion. And so if you're not familiar with dependency injection, it's worth getting familiar with the technique at least. Because if you look at what we did, injected a fake, or you can inject a real DD. So this is what that looks like in the picture. So if you see people for things like clean architecture, onion architecture, they're referring to this kind of diagram where all your code in the core is not dependent on details like exactly which DB you're hitting or whether it's being used by web app or CLI or a test. So all dependencies can only flow in this. So sometimes that's all clean. Sometimes we'll hear that as ports and adapters or hexagonal. It's the same idea. Hexagonal is just partitioning the stuff on the outside into different groups. So if you see diagrams like this, then this is a very simple example of that. Another any pattern, skip over. And these things just start to get more and more speculative as they go on. But, so basically at the end, so if you're having trouble mocking, think about refactoring more frequently. It's part of TDD that will help you not have problems with mocks. Consider other kinds of test levels besides mocks. Maybe fakes, maybe one is a dummy or a spy. If you're going to patch, that should be very rare, and it's the last resort you should go for. And then mocks, if you use them, think about trying to target roles instead of objects. And they're not really supposed to be just a tool for text isolation. So these guys gave me a bunch of feedback. They're very nice. By the books. And yeah, if you're interested in like reading more about this, here's some good resources. So, yeah, that's the end of my talk.
So thanks, I think this was an amazing talk. So we have a few minutes for some questions, if you have any. Any question?
One question. If you have dependencies in your functions, what do you do then? So if your functions need to be, if you wanted to unit test your functions, how would you do it? What would you do it?
So the answer is usually it depends, but my personal preference is to try to do some
If you have a function, sorry, if you're doing functional programming.
Oh, if you're doing functional programming.
Right.
Then what was the question?
Then how do you do unit tests?
Yes, so in that example, all the unit tests